My name is Manuel Lopez, and I'm with the Northern Arizona University Research Team. And the topic I will be discussing today is analysis of pavement conditions through vehicle-based sensing. So our team's challenge was developed with infrastructure development with emphasis to pavement conditions and relationship between vertical acceleration and the vibration of the pavement roughness sections. So the objective was to develop an integrated vehicle-based sensing model with a full car model in order to predict pavement conditions, pavement roughness, and even critical cracking locations. The methodology that we used for our research was we decided to take two sections of roadways along the I-10 corridor, both northbound, southbound, and then westbound, eastbound. Um, so our base foundational data that we obtained was IRI, which is the International Roughness Index, which is used for pavement profiling in order to see the relationship in vertical displacement along the pavement section of a roadway. So what we did in order to find correlations with those data points was use accelerometers, which are vertical displacement meters placed on a vehicle, which would be on the control arm of the tires. And the goal was to record vertical acceleration data along these pavement sections so that we can find correlation between those acceleration points and the IRI. So through numerical analysis, after we found the pavement sections and the vertical acceleration points, we brought those back into an analysis software, and from there we plugged it into our full car model in order to develop the graph that you see above at the results. So for northbound, southbound, I was able to develop a R squared coefficient of 0.86, which does show a strong correlation between RI and vertical acceleration. So what we want to see is a direct relationship. When we see an RI value that is high, we want to see a high uh, vertical acceleration point. When we see good RI, which is low, we want to see low responses from those tires. So in summary, the goal that we developed, the method we developed was able to predict pavement conditions, pavement roughness, and we were able to use those points to identify critical cracking locations. Some of these the applications that this could be used for is pavement maintenance scheduling, pavement rehabilitation, and also pavement preservation projects. So to recap on some of my figures here, figure 1 and 2, they show the sensors and the locations that the sensors were placed. Figure 3 is a snapshot of GIS, a spatial reference software used that shows where the IRI data points were collected and then where the acceleration points were collected in conjunction relates to the IRI. So, and then the smaller graph I have shown is a consolidated graph from both my partner's research and then mine. So our consolidated R-square value was a 0.85, which still maintains that strong correlation, which does kind of verify field data to IRI.